Hello students, my name is Sanket and welcome back to my world of mathematics in Sanket Sir's Maths Academy. Today we will see the statement and discuss the proof of the basic proportionality theorem, also known as Thale's theorem. Basic proportionality theorem or Thale's theorem. The statement of basic proportionality theorem states that if a line parallel to one side of a triangle intersects the other two sides in distinct points, then the line divides the two sides in the same ratio, that is in same proportion, right? In fact, proportion means that the ratios are same. Now, let us read and understand this statement with the help of the diagram. If a line parallel to one side of a triangle, so here if you observe, the line L is parallel to the side BC. So we have line L parallel to one side of the triangle, which is that side BC, for triangle ABC, right? Now, intersects the other two sides in distinct points. So L is parallel to BC. Which are the other two sides? The other two sides are AB and AC. So line L intersects AB and AC in which two distinct points? It intersects AB in point D and the line L intersects AC in point E. So line L intersects AB and AC in two distinct points D and E. Now, what do I have the explanation for that? Let us understand how we apply basic proportionality theorem and then we will go ahead and prove it. So, we consider in triangle ABC, line L intersects side AB and AC at points D and E respectively. Such that we need to show the parallel part also. So line L parallel to side BC, line L parallel to side BC. Then we can say by basic proportionality theorem or Thale's theorem, the line divides two sides in same ratio. What is same ratio? See, line L is dividing AB in two parts. Which are the two parts? AD and DB. Similarly, line L is dividing AC in two parts. Which are the two parts? AE and EC. We have to say that the ratio of the parts of AB, that is AD upon DB, should be equal to the ratio of the parts of AC. What are the parts of AC? AE and EC. So we say that the ratio of AD upon DB is equal to the ratio of AE upon EC is equal to AE upon EC by basic proportionality theorem. Let's now prove the basic proportionality theorem. Basic proportionality theorem stated that a line parallel to one side of a triangle intersects the other two sides in two distinct points. So here we have, this is the line L. So let me mention that name L as well. So this is the line L. So we have line L parallel to side BC. Line L is parallel to side BC of triangle ABC, and line L intersects sides AB and AC in points D and E respectively, which we have seen in our explanation also. So L intersects AB at point D, L intersects AC at point E. That's given. That's done about the given part of it. What did we have to prove? We had to prove that line L divides AB and AC in equal ratio, or line L divides AB and AC in proportion. Proportion means equal ratios, right? So what are the ratios? What are those equal ratios? The ratios are of the two parts of the sides of each. So of each side having two parts, AD and DB. So the ratio will be AD upon DB. The other side AC has two parts, AE and EC. So the ratio will be AE upon EC. We have to prove these ratios equal. So we have to prove AD upon DB is equal to AE upon EC. right? We have to prove AD upon DB is equal to AE upon EC. We have to prove that the two parts of each sides formed by intersection of line L, which in turn is parallel to BC. Those two parts of one side will be in a ratio which is equal to the ratio of the two parts of the other side. Hope we are clear with what is the aim of proving, what we have to prove in this particular proof. Now to prove that, there will be two additional lines we need to draw. We will mention them in the construction part of the proof. So I write construction. What have I mentioned here? Draw segment DC and segment EB. Observe students. This is segment DC from D to C and this is segment EB. So these two red lines are basically construction lines. Then let us move ahead. In our earlier videos, we have learned about triangles having equal heights and then what is the ratio of their areas. So here we will have two such examples where the triangles will have equal heights. So let's look at the proof. For the proof, what I have done is I have tried to take a small part of the original diagram and I have redrawn it below. So do you see this is a part of this original diagram ADEB. ADEB. So let us now focus on this part diagram. Here we know that triangle ADE, observe triangle ADE and BDE. ADE, that's the upper triangle. BDE, that's the lower triangle. If you observe, their sides AD and DB, they are on the same line, correct? ADB are collinear points. So AD and DB lie on the same line. And we can say they also have a common vertex E. They also have a common vertex E, which means these are triangles having equal heights. Do you remember, students, how we had learned about triangle with equal heights? Let us quickly have a glimpse of what we had learned. We had drawn triangles something like this. Right? We had drawn triangles something like this. And then we said, if I draw a perpendicular from this top vertex on the base, this is the perpendicular. Now this perpendicular will be a perpendicular for two triangles. Which are those two triangles? It can be perpendicular for this triangle also, and it can be perpendicular for this triangle also. See, observe carefully. So for this base, the same height h, and for this base, which is an obtuse angled triangle's base, the height will be still same. Correct? For obtuse angled triangle, the height is outside the triangle, but from the same vertex. So triangles having bases on the same line and having a common vertex have equal heights. So I have triangles ADE and BDE having bases AD and DB on the same line AB, and they have a common vertex and have a common vertex E. Therefore, what we know? We know that they have equal heights. So triangle ADE and BDE have equal heights. Then what did we know about the ratio of areas of the triangles? If triangles have equal heights, the ratio of their areas is equal to ratio of their bases. What are the bases here? AD and DB. So I will say ratio of area of ADE upon area of BDE is equal to ratio of their bases. What are the base? AD and DB. So I will write bases AD upon DB. A quick revision. We have triangles ADE and DBE having bases AD and DB on the same base, on the same line, and they have a common vertex E. Therefore, ratio of their areas is equal to ratio of their bases. This we can write as equation number 1. The reason you have to mention is a triangle with equal heights. Got it? Now let us again take the other side. Look here. A, D, E and C. Do you see this? A, D, C. If you draw this big triangle A, D, C with point E. Let me show you one more time. A, D, C. We draw this triangle and point E joint D, E. Here I have drawn ADC triangle, right? Point E, and then we have joined DE. So we consider this part. Again, in this part, we will consider triangle, the upper triangle ADE, and what is the lower triangle? CDE. ADE, CDE, do they have a common vertex D? Yes, common vertex D. Also, they have bases AE, EC on the same line AC. So triangle ADE, CDE have their bases AE and EC on same line AC and have common vertex D. We just saw that when bases are on the same line, they have a common vertex where heights are equal. So ADE and CDE have equal height. What happens when triangles have equal heights? The ratio of their areas is equal to ratio of their bases. So here, what are the bases? AE and EC. So ratio of area of ADE upon area of CDE is equal to ratio of their bases AE upon EC. AE upon EC. Let's write this as equation number 2. Again, the reason you will write triangles with equal heights. So we have got, if you observe here in the first equation, AD upon DB as area ADE upon area BDE and AE upon EC as area ADE upon area CDE. Observe the left side of the two equations. The numerators are same, area of ADE, area of ADE. But the denominators, area of BDE and area of CDE. We have to prove that area of BDE and area of CDE should be equal. Let us see how we prove the denominators equal. The numerators are already equal. Again, I go back to the main triangle and the lower part. Look at the lower part. Line L parallel to BC. DE are the intersecting points. BC are the vertices of triangle. And we have joined DC and EB. Focus on this part. I have redrawn it here. Correct? Same triangle ABC. Line L, I have only drawn the part DE and which is parallel to BC. Shall we mention the symbols of parallel lines? We can mention it like this. Right? Then we see that I have shaded two triangles here. Triangle BDE is the one which is shaded in green. Triangle CDE is one which is shaded in purple. And these two triangles are lying between the two parallel lines DE and BC. So I say triangle BDE and CDE lie between same two parallel lines DE and BC. What do we remember about triangles lying between same two parallel lines? Do we do a quick revision of that? So when there are two parallel lines, I am taking the lines on the page, and if there is one triangle like this, if there is a other triangle, I am extending this here. Here the height will be this, perpendicular height. The height will be from bottom to top, perpendicular height. But if you observe these heights, I am drawing another color here. These heights, the green colored lines, are basically the distance between parallel lines. Now parallel lines will always have same distance between them. Always. They never intersect. They are parallel. So here the lines are parallel. So the distance between them is the same. Here the heights of the triangles are same. And therefore triangle BDE and CDE will have equal height. So triangle BDE and CDE have equal heights. So we have triangles with equal heights. Done. What did we know about triangles with equal heights? That ratio of areas is equal to ratio of bases. Observe, students. Here for BDE, I can take DE as the base. For CDE, I can take DE as the base. So practically, I can write ratio of areas is base DE upon DE. Isn't it common base for both? Yes, they also have common base DE. What will happen for DE here? We can cancel DE from numerator denominator, and what will I get after cancellation? It will be equal to, the ratio of areas will be equal to simply 1. Now, if you observe, that area of triangle CDE can go on the right side, gets multiplied with 1, and I will have area of BDE is equal to area of CDE. Now, when we write this ratio of areas is equal to DE upon DE, we mentioned triangles with equal heights, and we make it 1, so it is also with equal bases. Therefore, area of BDE and area of CDE become equal. Let us call this equation number 3. Now, what were the 3 equations we have derived till now? Let's go up and quickly have a look at it. The first equation, area ADE, area BDE, AD upon DB. Let's write it separately. Equation 1, area ADE, area BDE, AD upon DB. What was equation 2? Equation 2 said area ADE and upon area CDE was AE upon EC. Area ADE upon area CDE was AE upon EB, equation 2. Equation 3, we proved that area of BDE and area of CDE are equal. Area of BDE and CDE are equal. Observe equations 1, 2 and 3 carefully. If you look at equation 1 and equation 2's left hand side, the numerators are equal. The numerators are equal. The denominators are not equal. But we have proved the denominators equal in the third equation, BDE, BDE and CDE, CDE. So basically equation 1 and 2, left hand side numerator equal, left hand side denominators equal. So entire left hand side equal. Therefore, can't I say that the entire right hand side will also be equal? That is AD upon DB equal to AE upon EB. AD upon DB equal to AE upon EB is exactly what we had to prove. AD upon DB is equal to AE upon EC. So we have here in equation 1, we had area of ADE upon area of BDE as AD upon DB. So I write this down here. Area of ADE upon area of BDE as AD upon DB. Equation 2, area ADE upon CDE was AE upon EC. So I write here area ADE upon CDE, AE upon EC. And we also proved that area of BDE and CDE are equal. BDE and CDE are equal. That was equation 3. Observe the 3 equations very carefully. In the 3 equations, equation 1 and 2, left hand side numerators area ADE and area ADE equal. The denominators, if you observe, BDE and CDE were not equal, but in third equation we proved even that equal. Area BDE is, we have proved equal to area CDE. So practically what we have proved is the entire left hand side of equation 1 is equal to entire left hand side of equation 2. If left hand sides are equal, right hand sides also equal. Therefore, AD upon DB will be equal to AE upon EC. AD upon DB is equal to AE upon EC, which is exactly what we had to prove. AD upon DB is equal to AE upon EC. Thus, we have proved the basic proportionality theorem. Let's quickly have a revision about what basic proportionality theorem means or states. It states that in a triangle ABC, if a line is parallel to one side and intersects other two sides in distinct points, then the ratio of the two parts of one side is equal to the ratio of the two parts of the other side, or it divides the sides in proportion. That was your basic proportionality theorem and its proof. Question 1, we had area of ADE upon area of BDE as AD upon DB. So I write this down here. Area of ADE upon area of BDE as AD upon DB. Equation 2, area ADE upon CDE was AE upon EC. So I write here area ADE upon CDE, AE upon EC. And we also proved that area of BDE and CDE are equal. BDE and CDE are equal. That was equation 3. Observe the three equations very carefully. In the three equations, equation 1 and 2, left hand side numerators area ADE and area ADE equal. The denominators, if you observe, BDE and CDE were not equal, but in third equation we proved even that equal. Area BDE is, we have proved, equal to area CDE. So practically what we have proved is the entire left hand side of equation 1 is equal to entire left hand side of equation 2. If left hand sides are equal, right hand sides also equal. Therefore, AD upon DB will be equal to AE upon EC. AD upon DB is equal to AE upon EC, which is exactly what we had to prove. AD upon DB is equal to AE upon EC. Thus, we have proved the basic proportionality theorem. Let's quickly have a revision about what basic proportionality theorem means or states. It states that in a triangle ABC, if a line is parallel to one side and intersects other two sides in distinct points, then the ratio of the two parts of one side is equal to the ratio of the two parts of the other side, or it divides the sides in proportion. That was your basic proportionality theorem and its proof.